Hello friends, welcome back to my channel. So friends, till now we have seen the basics of LGIP engine. Now for operation of this engine, we have to see a little bit about the main operating panel, that is the MOP. So the MOP for this LGIP engine is very much similar to the MOP which is used for the normal ME engines. But few extra things are incorporated in this MOP for the LGIP engine to change over the main engine from primary fuel to secondary fuel. So let's study a little bit about the MOP or the integration of dual fuel system into the normal ME engine MOP. So this is the first screen of MOP from where we can change over the LGIP engine from primary fuel to secondary fuel mode. So for changing over the primary fuel to secondary fuel mode, few conditions are to be met, then only we can carry out the changeover. So we all know that the starting of the engine, after starting the loading up, then low load operation and stopping of the engine. So basically all these operations are basically carried out or basically possible only on primary fuel mode. So starting, loading, low load operation and stopping of the engine, they can only be carried out when the engine is running on primary fuel mode. In order to carry out the changeover for the operation of engine on dual fuel mode, the engine has to be running with a minimum fuel index. Like suppose you can say it will basically depend upon engine to engine. Like for my engine it was 20% fuel index. So when we need to change over or when we want to change over the main engine from primary fuel to secondary fuel mode, then at that time we have to see, or basically we have to fulfill various conditions as you can see over here. So these are the few conditions which are to be met, then only we will be able to change over the engine from primary fuel to secondary fuel mode. So as you can see over here, this dual fuel status, so over here it is showing ready status. So this ready status will basically come only when all these conditions are met. So after all these conditions are met, then only you will have this ready status. Otherwise the ready status over here it will show not ready, or basically dual fuel system is not ready. So once the dual fuel system is ready, then we can press this button, and then after that we will come down over here and we can press this start button for the operation of main engine from primary fuel to secondary fuel, or basically the changeover of engine from primary fuel to secondary fuel. So when we press this start button, then this ready symbol over here or the ready status will change over to starting. Okay, over here then after pressing start button it will come as starting. So starting will basically mean that the engine is basically carrying out few checks for the operation of main engine on dual fuel mode. So when all the checks are carried out and engine has fully changed over from primary fuel to secondary fuel, then at that time the status will change from starting to running. And the last status that will come over here is the stopping. So basically when we are changing over from secondary fuel to primary fuel, then at that time over here it will show stopping. So all these status will be indicated on this button. And for stopping, as I have already told you, we have to press this button, then we will come over here and we have to press this stop button. Then pressing the stop button will basically initiate a few process, or basically purging out operation for the double wall pipes, and then only the engine will be stopped. Now the next thing which you will see on this screen is this fuel index. So as you can see over here, this is basically showing the quantity of or the amount of fuel index which is for the primary fuel. So when the engine is basically changed over from primary fuel to secondary fuel, then at that time this blue color will change gradually from blue color to gray color. So basically this will gradually, or basically the secondary fuel will enter into engine very slowly, and it will be injected, and secondary fuel will be injected and the primary fuel quantity will be reduced, and this gradual changeover will carry out till the secondary fuel has basically secondary fuel index has basically reached 90% and primary fuel is only 5%. So This is the condition that will come when the engine has fully changed over from primary fuel to secondary fuel. You must be thinking that why 95%, why not 100% secondary fuel? So as I have already told, or if you have understood the basics of dual fuel engine, so these engines basically cannot operate individually only on one fuel, that is the LPG. So for burning the LPG in the combustion chamber, we require small amount of pilot fuel. So this pilot fuel is basically the primary fuel only, but the quantity of this pilot fuel has basically decreased to 5%, and 95% is basically the dual fuel. So this is the first screen of the MOP. So from the first screen, we can basically carry out the changeover process of primary fuel to secondary fuel. Then for monitoring the changeover process, and basically for detecting any kind of fault in the secondary fuel system, we have a separate tab for the secondary fuel oil system over here under auxiliaries. So in this tab, we can basically monitor the whole changeover process, like what is going on during the changeover process. So for that, we have the status tab over here. In the status, we can see what all conditions are met, and where we need to carry out some work for meeting the criteria for changing over the main engine to secondary fuel. Then during changeover process, or basically carrying out the assembly test and the purging operation, uh, line pressurization, pressure test, everything we can monitor from all these tabs, which you can see over here. So this is a secondary fuel supply system. So we can monitor the secondary fuel supply system during changeover. Then secondary fuel return system. Then we can see the outer pipe, then the sealing oil, and then cylinder monitoring. So basically we will see all the tabs screen separately in detail. In this we will just see the status. So as you can see over here, these are the conditions that need to be met for the main engine to be changed over from primary fuel to secondary fuel. So as you can see over here, it is showing not ready because these two and these two are these four conditions are not met. Like over here, these four conditions are not met, but in your system it could be anything. Oh, basically this tick, this is green tick, shows that the condition is met. So if this green tick is not there, means that the condition is not met. So for the changeover of the system to secondary fuel mode or dual fuel mode or secondary fuel mode, we have to meet all the conditions, then only we will be able to carry out the changeover. So this is about the status. So if this is met, we can change over the process. So I have already told you that when the conditions are met, then the this status will change to ready status. Then by clicking on the ready button, or basically dual fuel ready button, then then pressing the start button, the process of changeover will start. So we will see how the changeover basically takes place. So before we basically see the process, we have to see the MOP for the secondary fuel supply system, then return, then outer pipe, then sealing oil, then cylinder monitoring, and then finally we will go for the whole changeover process. So let's carry out the screen for the secondary fuel supply piping or supply system. So this is the screen for the secondary fuel piping for the supply system. So as you can see on the screen, this is the inert gas system. So this inert gas system is basically the nitrogen generator that provides nitrogen at around 34 bar for the pressure test of the double wall piping, plus the purging of these piping during the starting as well as stopping process. Then we have these valves. So all the valves on this screen, as you can see, so these valves are basically operated from the operated automatically from the ECS command. So basically these valves are controlled by the engine control system. So we cannot basically operate these valves manually. Now we have this supply system. So this supply system basically represents the deck tank as well as the FGSS, that is the fuel gas supply system. So this system basically provides LPG at around 50 bars to the to this point. This point is basically the inlet to the fuel wall train, or basically the supply fuel wall train. So this section over here basically represents the fuel wall supply train. So on this there is a filter, then these walls are there that are basically controlled automatically from the engine control system for carrying out the purging operation and the pressure test. Then we have this orifice which is there on the fuel wall train for gradually filling of the main engine, so that pressure fluctuation is not there in the system. This system is basically too much sensitive to pressure fluctuations. Any kind of pressure fluctuation is there, we won't be able to start the system. So for that purpose, this orifice is there, which is used, or which is very helpful during filling of the main engine during starting process. So with the help of this, the engine is filled very gradually so that pressure fluctuations are not there. So once the engine is filled, then this valve will open for the changeover of main engine from primary fuel to secondary fuel. Then on this screen we have this the FVIV. So this FVIV basically represents the main engine. So this FVIV basically shows the cylinder head, or represents the cylinder head of the main engine. These are the inlet and the outlet valves, and this is the bypass valve for this FVIV. Then we have this plant status indicator. So this indication will basically show the current status of the main engine. So basically during starting process, what is the current status, that is what kind of test is basically going on. Like suppose the supply system is tested, or fuel wall train is tested, or return wall train is tested, that will be shown over here. Then we have the indication for the safety system. So this basically represents whether the safety system is normal or there is some kind of problem. Then this is basically indicated over here. Then we have this assembly test and the purge request. So this button is basically provided for carrying out assembly test of the double wall piping after any kind of maintenance is carried out on the main engine. So with the help of this button, we can basically manually carry out the assembly test, or basically pressure test of the double wall piping, so that we can check if the secondary fuel system is intact and any kind of leakage is not there. So I think I have covered everything on this supply system. Now let's go on to the secondary fuel return system. So on this secondary fuel return system, the LPG basically enters from the supply fuel wall train, and then it goes on to the main engine cylinder head, that is the FVIV. All these walls I have already told you, which are there on this screen, they are basically operated from the engine control system automatically. So the LPG basically enters this FVIV cylinder head, and then it is returned back to the supply system via this return wall train, return fuel wall train. On this you can see return wall train is basically shown by this section, but in reality this whole section basically represents the return wall train. So in this return wall train, as you can see, these two walls are there, which is directly venting out the LPG to the vent mass. So when engine is stopped with any kind of abnormality, which can be because of any kind of safety reasons, then at that time this outlet valve to the engine or the supply system will be shut, and the leftover LPG which is there in the piping, that will be purged out directly to the vent mass with the help of these two valves. Then we have this pressure control valve. So this pressure control valve basically maintains the back pressure in the engine. So this pressure control valve basically, with the help of engine control system, basically opens to that extent that maintains the pressure in the supply line. Then we have the sensor. As you can see, this sensor basically, you can say this is the level sensor that basically indicates dry or wet condition. So when the engine is fully filled with LPG, then the system will change over, or the indication will change over from dry to wet. So that basically gives indication that the engine is fully ready for the changeover to secondary fuel mode. And this valve, as you can see, this is also vented to the atmosphere, but this valve is used or opened when the system has fully stopped. Basically this valve and this valve will be closed and this valve will be opened. So this system is basically called the block and bleed system. So this valve will be opened, so this basically will fully isolate the supply system from the main engine. And all these three indications I have already told you in the previous screen. So I think I have covered everything in the return supply system, or this secondary fuel return system. So now let's go on to the outer piping. So now we will see the outer piping. So the operation of basically the flow diagram for the outer piping we have already covered in my previous videos, but still I will give you the overview. So this is the dry air which is produced in the engine room by the air compressors, and this dry air is supplied from and it enters the double wall piping. So this basically enters at the return side. So this is the this line over here, as you can see, this is the return of LPG, and the outer periphery or the annular space is basically supplied with dry air, and this enters the engine, as you can see, engine room. This enters the engine room, and then it is vented out to the atmosphere, as you can see, like this it is vented out to the atmosphere. And this is the LPG inlet. So the inner pipe under in the inner pipe of this double wall piping, the LPG is supplied, and on the outer annular space the dry air is supplied, and the flow of these two are basically in the opposite directions. Now on to this double wall piping, or basically the outer pipe, a ventilation fan is provided. So the indication is shown over here, it is whether it is running or it is stopped. Then we have two sensors two HC sensors installed onto this outer pipe. So that basically detects the LEL percentage. So if the percentage goes high, then the system will be stopped, or basically emergency stop will be carried out. Then we have the walls for carrying out the testing of this double wall piping, as you can see over here. So 7 bar air is supplied from here, and with the help of these two walls the double wall piping is tested from the deck to the engine room, and from the engine room to the deck. So this basically is there is a sequence for carrying out the outer pipe test. Like when the test is carried out, this fan will be stopped, and when the this air is supplied at 7 bar, then at that time these two walls are shut, and time is monitored, and if for that particular period of time if pressure drop is not there, then only this test is passed. This basically shows the ventilation mode, whether it is in auto or manual mode. Basically it is always remained in auto condition. So I think I have covered everything on the on this outer pipe screen. So now let's go on to the next screen, that is the sealing oil system. So in the sealing oil system, the hydraulic oil which is at around 250 bar is basically reduced to 80 bar, and this reduced pressure or reduced hydraulic oil at around 80 bar is supplied to the FVIV. So the sealing oil pressure is shown over here. So this pressure is basically acting as a safety for the FVIV. So this 80 bar pressure hydraulic oil is supplied in between the hydraulic oil for the operation of FVIV at around 250 bar and the LPG. So in between that section in the FVIV, the sealing oil is provided at 80 bar for the safe operation of the main engine on the dual fuel mode. So this system is always maintained in auto condition. And during my tenure on the ship, there was a test going on for reducing the seal oil pressure from 80 bar to 65 bar. So basically we were trying to reduce the sealing oil pressure so that the amount of oil which is going into the engine and it is clogging the nozzles, so that can be reduced. So for that purpose the sealing oil pressure may be reduced in future from 80 to 65 bars. So now we will see the cylinder monitoring tab. So in this screen, as you can say, basically this monitors the conversion process of all the units. Like over here, this represents the unit number, and these are the processes which are monitored. So basically the compression pressure is monitored, then maximum cylinder pressure is monitored, then LV signal is monitored, then expansion pressure is monitored, then we have rate of pressure rise is also monitored, and then the inlet gas pressure of the LPG is monitored. So all these things are very important for the operation of main engine on dual fuel mode. Now it is looking very simple, like if green tick is there, then the system is working fine, and if green tick is not there, then there will be an alarm, or the system will be abnormal. But all these things are very important to monitor the combustion process of these engines, because suppose if let's say the main engine is operating on dual fuel mode and it misfires, so what will happen? The LPG which is injected into the combustion chamber, what will happen to that LPG? It will get released into the scavenge space, so that will lead to scavenge fire. So to avoid that, all these parameters are monitored. So not on this video, but I'll try to cover the importance of few parameters that are very important for the operation of these engines in the dual fuel mode. Because if those parameters are not monitored, then the basically the combustion process that can affect the safety of the engine, or there could be disastrous incidents that can take place if these things are not monitored properly by the engine control system. Now we will see the next thing, that is the pilot profile of the engine. So let's go on to the pilot profile screen of this MOP. So now we will discuss about the pilot oil profile screen. So under process adjustment tab, we can find this pilot profile screen. So if the main engine is running on dual fuel mode, then this pilot profile will show active. Like over here it's showing not active, means that the main engine is basically running on primary fuel. So when the engine is changed over to secondary fuel, then this pilot profile will show active. So basically we can adjust the amount of pilot fuel by adjusting the uh, pilot profile of the injector. Like suppose we want to adjust for number 4 unit, so we have to basically come over here, come on to this screen and click on this, and then with the help of these buttons we can control the, or we can adjust the pilot profile of the pilot profile of that particular unit. Now the question comes, why do we need to adjust the pilot profile? Like suppose we have some problem with the injector. So the amount of pilot oil which is needed for the combustion of the LPG, that is not injected, and if that conditions take place, then at that time there will be knocking in the engine. So we have a little bit control onto the pilot profile. So basically we can come onto this screen, and with the help of this screen we can adjust the pilot profile. We can basically increase or decrease the pilot profile, and for the proper combustion of the LPG into the combustion chamber of this LGIP engines. And we can see the basically whether the amount of oil is after, suppose we have increased the pilot profile of the particular unit, we can monitor with the help of this fuel plunger stroke. So if the fuel plunger stroke increases, then that means that the amount of oil injecting or injected as a pilot fuel has increased. So with the help of this fuel plunger stroke, we can monitor, or we can check whether the pilot profile has increased or not. So with the help of this, we can basically improve the combustion process in the main engine. So I think I have tried to cover most of the things that are needed for the operation of main engine onto the dual fuel mode. If you have any, if you need any other information regarding the MOP, you can tell me, and I will try to help you out. So next thing that I'm going to cover will be the starting sequence, or basically how the changeover takes place from primary fuel to secondary fuel. So that I'm going to cover in the next video. So till then, take care, have fun.